This is problem 3.5. So calculate the formula weight of the following compounds. So the first one is sucrose, okay, which gives us the formula, the molecular formula, which is C12H22O11. And so if we break this down, we know that we have 12 carbons, we have 22 hydrogens, and we have 11 oxygen. Okay, and so for each one of those, then we can calculate the total atomic weight of each one. So we have 12 carbons, and we know that the mass number or atomic mass is 12.01 AMU. Okay, and so that's going to be equal to basically 144.0 AMU. For hydrogen, we have 22 times its atomic mass, which is 1.01 or 1.0 AMU, and so that's going to be equal to about 22.0 AMU. And then for oxygen, we have 11 times 16.0 AMU, which gives us a total of 176.0 AMU. And then to get the formula weight of the entire formula, we just add all those up, which is 342.0 AMU. Okay, so if we go to the next problem, okay, which is calcium nitrate. All right, calcium nitrate breaks up into calcium, Ca2+, and nitrate, which is NO3-. Okay, and so together that gives us, if we bring those together, we have CaNO3-2. Right, so when we make the ionic compound, we can write that out. And so once again, we can just add up what we have. We have 1 calcium, we have 2 nitrogens, okay, and we have 6 total oxygen. And so then we can just calculate each of those individual weights and then add those together for the overall formula weight. So we have 1 times 12.0 for the calcium. Oh, I'm sorry, that's 40.0. So 40.0, okay, and so that's going to be equal to 40.0. Then we have 2 nitrogens, so 2 times 14.0 equals a total of 28.0. And for the oxygen, we have 6 times 16.0 for a total of 96.0. And if we add all of those up, we get 164.1 AMU. Alright, so the next one we have is aluminum hydroxide. And so if we write this out, we have Al3+, and then we have hydroxide, so OH-. Okay, so those combine together to give us AlOH3. Okay, so then we can say, all right, well, we have 1 aluminum, we have 3 oxygen, and 3 hydrogen. Okay, so we can calculate each of these weights individually. So for aluminum, we have 26.98 times 1, so we have 26.98 AMU. For oxygen, we have 3 times 16.0, so we have a total of 48.0. Okay, and for the hydrogens, we have 3 times 1.0, which is going to be 3.0. We add those up, and we have about 77.98 AMU. Alright, so for the last one, we have propanol. Okay, so with propanol, we know that we have propane, which means that we have 3 carbons, so C3. We have an OH, okay, and so then we must have some number of hydrogens left over. So if we draw this out, we have 1, 2, 3 carbons with the hydroxide. We have then 1, 2, 3, 4, 5, 6, 7 hydrogens that we can add to this. Okay. So we know we have C3H7OH, so then to add up that molecular formula, we have 3 carbons, we have a total of 8 hydrogens, 1 oxygen, and so then we can calculate each one of these. 3 times 12.0 is equal to 36.0 AMU. We have 8 times 1.0 for the hydrogen, so 8.0 AMU. And lastly, we have 1 oxygen at 16.0. So 16.0 AMU. So we have a total of 60 for our formula weight for propanol.